Hello everyone. I have been eagerly waiting to bring you today's video. Our topic is broadly about integration today, and more specifically integration by parts. In fact, the genesis of this video is right here on your screen, the question what you can see on the screen. In this question, as you can see, we are asked to find out the function gx. And the standard approach to solve this question is to differentiate the given equation, both hand sides with respect to x of course, and compare the like terms from both sides and solve for gx. And indeed, most resources you will find offer this very solution. But can we think deeper? Can we think better? Think like this. What if the expression on the right hand side was not given to us in such a hinting form to apply the differentiation? How would we find the integral purely from scratch of such kind of integrand? Moreover, this is not the only question of its kind. There are many problems that follow a similar hidden structure. So through this video, my attempt is to equip you with a technique. The technique for identifying the format of such questions and transforming them into a structure that leads you to the answer in just a few steps. And believe me, this is not just a quick fix or shortcuts or any trick. This is an invitation. I believe this is an invitation to understand and appreciate the profound elegance hidden in this technique of integration, what we call integration by parts. Let's dive in. Alright, so let's dive in and we will see what structure I am talking about and how we can develop a formula to apply in such kind of questions easily to find the answer in few steps. So we have to first observe the integrand, in which three things we have to think. The first is f of ux, means the composition of f and ux, and you must have the derivative of ux there, that is u dash x, and a third function, that is the gx. If this happens anywhere, you can apply the integration by parts. And how we can apply it? Because we know that the f of ux has its derivative already, so we can take gx as the ux, means the first function, and we are integrating the f of ux and u dash x with respect to dx, minus we are going to differentiate this g, this is g dash x, and again the integration of this whole thing, that is f of ux u dash x dx and the whole dx. This is the integration by parts we applied. But how the formula will come out, let's see. You notice I have written there the function, the small function fx as the integral, the f capital fx. So I have this gx, and this I can write now the capital F of ux. You can see, and you can just visualize this thing and calculate in mind, because if we substitute ux as t, its derivative is already there, so small ft dt will be there, a small ft dt, whose integration will become capital Ft, and so we can write capital F ux, and minus this I can write g dash x, and again this whole thing what we have done here I can write as capital F ux dx. Now if you observe this whole thing, you can see I can bring this minus sign that side. So I will have the f of ux into u dash x into gx dx plus integration of g dash x f of ux dx is our g of x capital F of ux, and plus c we can add at the end. So this is the technique I'm talking about. We can also club this integral together. And how we can club it? We can maybe you can just memorize or understand. This is our final result. And I suggest that try to separate into two integration. It will be useful in calculation. If you want to combine this integration, you can also do it. Means you can write it like this: f of ux u dash x gx plus g dash x capital F of ux, and this whole integration, and that will give you gx f of ux plus c. So this is the result. Now let's apply this in this very warm-up example. We will see that example also what I showed you in the beginning. So here you can observe what I'm talking about is this. You can observe that. Can we find this structure here? F ux u dash x gx. If this structure you can find, even if you don't know the formula directly or you don't know the structure or all this development, you can apply this integration by parts here only, and everything will be smooth after. So I'm not saying that you have to mug up the entire result, but believe me, if you practice few questions, the result will be committed to your memory. So what we can do here, we can simply see that this sign is our small f, and inside it I have this is small fx, and inside it there is a ux. So ux I am taking as sin x, and you notice there are two cos x attached here. So one cos x I can write as u dash x, and the other cos x, what is left out, I can write as gx. So don't you think it is the same structure? Because it is f of ux into u dash x into gx. It means I have to now observe the second half of this whole integrand, or maybe the second integral you can say. Like if I detach this thing like this, the second integral for this formula, or the second half of the integrand this formula. And what does it say? I need the derivative of gx and the integral of the small f. Inside that I need ux. So I have this sin x. You can observe, if I have gx is cos x, sin x, what is g dash x actually? G dash x is minus sin x. And now I have fx, small f is sine, so we integrate it, so I'll get capital Fx as minus cosine x. And you notice this sign is inside it. So our gx was cos x, but the ux was sin x. So I can say that the capital F of ux is nothing but minus of cosine of sin x. And you see this minus sign here and this minus sign here will be multiplied to get the plus sign in front. And so the exactly same structure. So we can write the integral as gx times f of ux. Means what you have written there, we have to write this thing. So what is that? Gx is our cos x, and f of ux means you can also find from here the f of ux means what? Find the integral of sine, this first small f, and make the composition with ux. So integral of sine is minus cosine and inside it I have to put sine, and this will be our answer with plus c. So in this way we can solve this question easily if you understand this structure, and you believe me, this will be useful for many such complicated questions. Let's see another example. So I have this example here, and let me just bring it a little up. So this example says that I have one more thing. If I have the e to the power x as the small f, it will be easy to integrate. Why? Because now the formula will turn into a very nice structure. Let's see how. Because you notice in this formula over here, let me bring it a little down and I will show you what I want to say. If I have small f will become, when I am saying the fx is e to the power x, it means in this whole structure what you observe that you can write it as e to the power ux and then u dash x into gx plus g dash x, and notice the integral of e to the power x is e to the power x only, so this will give you the again e to the power ux only, and this will lead us to write the gx into e to the power ux. But to frame a question, now it will be actually one tricky thing is happening. To frame a question, you can bring this e to the power ux out, and so we have u dash x gx and plus g dash x. So in this way we have to only observe this structure, that the u dash x gx plus g dash x, and we get gx into e to the power ux plus c. So whenever I have e to the power x as the small f, then we can apply this technique as well. So this is what the second part will become, e to the power x square and sine of 2x dx. And this is the structure we got it, and we can see what is happening there is I have, this is ux, this is u dash x, this is our gx, correct? And now I have to search there whether, what is the formula you see here? I need g dash x into e to the power ux. So e to the power ux is the same e to the power ux. Now I have to only find the g dash x. So what is the g dash x? So if I have this as gx is sine 2x, so I have g dash x is 2 cosine 2x, which is already there. I have done a mistake here in writing that. So that was, I was wondering where the answer is. The 2 cosine 2x. But notice I will multiply this half outside of the whole bracket. I must have half over there also. And once I write this thing, this is g dash x is 2 cosine 2x. So cosine 2 cosine 2x, I can compensate it by multiplying with 2 there, and so we got the same structures. Our answer should be gx into e to the power ux. So I have gx as sine 2x, and e to the power ux is nothing but e to the power x square, and that is our answer. If you can also apply the integration by parts here and do it, but I suggest you can try a few questions and you can get that thing. Let's now go to our main question from where we started. So see, in this particular question, we see that I have e to the power x plus e to the power minus x. And notice I have no sign or no indication of this derivative anywhere, because this is, I'm assuming as ux, so the derivative of this function should be attached there. There's a u dash x is not there. how can we show it up in this whole process? This is our challenge. So let's see how we are showing it up and how the structure I'm making. So this is our left hand side. We have to deal with that without differentiating both hand sides. And my claim is we can convert into that structure. How? Let's see. So we can notice that the derivative of e to the power x plus e to the power minus x is e to the power x minus e to the power minus x. It means this term I have to show up there. How? Let's think. I can think that e to the power 2x I'm taking with minus 1, and this e to the power x 2 times what is given there, I'm writing 2 times, like e to the power x plus e to the power x and minus e to the power minus x dx. And now what I'm doing is I have to show up e to the power x minus e to the power minus x with this guy. I'm taking e to the power x common from this bracket. So this will give you e to the power x out and e to the power x minus e to the power minus x and plus e to the power x plus e to the power x minus e to the power minus x. Now we observe it that from these two terms I can take e to the power x minus e to the power minus x common. So I will write it here, e to the power x, e to the power minus x, like this. And after taking common, what we are getting is e to the power x minus e to the power minus x. And we are left with, please understand what I'm saying. I am taking this two terms and taking common e to the power x minus e to the power minus x from them. So this I took common, so I'm left with this e to the power x here and plus 1 here. And since I'm taking these two together, I multiplied with this, so I have one duty left. What this duty is, I have to multiply this with that term also. So this is dx, and I'm taking this whole thing separately with another integration. This is e to the power x, e to the power minus x into e to the power x dx. And now notice what is happening. It's already there, you have the answer. Why? Because I'm saying that this is our f of ux, where ux I have e to the power x plus e to the power minus x. This guy is our derivative of ux, that is u to the power u dash x, by the way. And this I'm talking about the gx. If this is our gx, in the second integral or the second integrand should be the derivative of g dash x should have actually this g dash x, and I must have the integration of small f, and inside this ux should be there. You see that this is nothing but the capital F of ux, and so our answer will be what? The gx. So gx is e to the power x plus 1 and into the f of ux. It means I have to take only this part. This is e to the power x plus e to the power minus x and plus c. And now for the question, if you compare, you get that the same thing there. So gx is nothing but I have e to the power x plus 1. And to find this g0, our answer should be 2, as we substitute 0 in this function e to the power x plus 1. So this question was asked, as you can see, in 2020 JEE Main. So this can be done in this way. Now another question we have. Let's see if we can do it. And you can notice there is a similar test, because again we have to find fx. But what we can think here, we can think that I have e to the power sec x, and I'm multiplying this e to the power x to both or all the terms together. So I have e to the power sec x into sec x tan x and into fx dx. And the other term, because why I'm always separating, because see that I have this ux and this is u dash x. It means I'm intended to assume this as gx. So I have here what? Left is e to the power sec x into sec x tan x plus sec square x, and I have e to the power sec x tan x fx dx plus e to the power sec x, and from these two terms I can take sec x common. If I take sec x common, I'm left with tan x plus sec square x. But notice, if I am intended to take fx here, whatever I see, because I have this structure, I'm getting this fx. So it means that it is following this structure. So if I have this fx, I must have this whole thing, what I am seeing must be f dash x. Then only this result will come. So this f dash x must be sec x tan x plus, I must have a sec x here, sec square x. And so in order to find fx, I can integrate it. So sec x tan x is integration sec x, and sec square x as tan x. So I have the value of fx as sec x plus tan x, the definition of fx. And they're asking then which is the possible choice. So I can say sec x plus tan x plus half, because, or minus half we can also take. So might be there is an option incorrect, because maybe I have typed it wrong. So only one option should be there in this data structure, sec x plus tan x, so you can get that. Alright, again there is another question like this. It was asked in 2023. Let's do it, how we can proceed. So you see that again I have e to the power sine square x, and I have cos x sine 2x minus sine x dx. And the approach is again simple. I notice that there's a sine 2x is there, so we have e to the power sine square x, sine 2x and cos x, and I can write this thing as plus sine and e to the power sine square x into minus sine x. And notice all thing is smooth. You see that this is our ux, this is our u dash x. So I am assuming this as gx, whose derivative is already there. So our answer is gx is cos x, and this is f of ux, so e to the power sine square x plus cos x. And after that, any student can do by substituting 0 in this expression to find out c, and then we can find pi by 3. So that's not a difficult task. Now let's apply this technique in this giant question, and this question is actually everywhere in all the guides, and their integration by part they have done many times. So let's try to think this question in this light. So I have e to the power x sine x plus cos x, and any student who is a little bit sincere or serious about his IIT preparation knows that the derivative of x sine x plus cos x is x cos x. And if you don't know, we can simply differentiate it and check it, what is the derivative of this expression, because I need the derivative there, then only this structure will work. So the derivative of x sine x plus cos x is, we can differentiate it here and see, x sine x plus cos x. So you apply here product rule in the first term. So it'll give you x cos x plus, not plus, it's a minus sign. Sorry, yes, plus. Sorry, it's a plus sin x. And there's a minus sin x for cos x. So this will give you x cos x. So I'm hoping this structure will work, and in 90% chances it will work in such type of situation if I have e to the power ux format. So I'm hoping that it will work. So I'm just multiplying x cos x, and to compensate it I'm dividing by it. So that will give you x cubed cos cubed x, and here x to the power 4 cos cube x minus x sin x plus cos x. So my point is here, even if you don't know the entire result, you don't want to mug up, and you rely on your solving skill, at least you can just remember the structure, and from there you can apply the integration by parts. Automatically everything will come into the place. So after that, what I need actually, I must need one gx. So this giant gx we cannot take, because our structure is to convert into two parts. So what I'm doing for that, I am writing this x sin x plus cos x as it is. Of course, this I'm writing in hope of this will work, and this I'm separating it. So if you separate it, this will give you x, the first term, and minus what I get here is, this will give you sin x with a minus sign I've taken, so there will be x sin x minus cos x, and I can write like this, I think, and this is x cube cos cube x. I have not done anything in this part. Okay, so natural, I can also see, the thing is, my point is, even if the student doesn't know how to approach after this, at least he can think something here, that this x I can take here outside of it and distribute it two parts, two integration. So x will serve a gx for us, correct? And that may lead us to a new step which will be easier to proceed from. So for that, we are doing it like this: e to the power x sin x plus cos x into x cosine x and into x dx, and this other integral I have is e to the power x sin x plus cosine x into x cosine x into this whole thing, x sin x minus cosine x divided by x cube cos cube x. But you notice, by any chance we cannot get the derivative of x, this whole thing, because I need only this part, and this whole part should come as the derivative of the gx here. So there is no hope, you can see the first place, but there is a hope here. How? I'm assuming this as gx, or you can think I'm just applying the integration by parts here. So if you assume this gx also, we can use the formula by taking the second integrand to the right hand side. It means you are actually applying the integration by parts in disguise. So what you write here, the gx into this integration, that is the capital F what I was talking about, and minus, you have to write again the same thing, the derivative of the g dash x, there is 1, and then capital F. So capital F is what? E to the power x sin x plus cosine x dx. Alright, and here I have minus of e the power sine x, x sine x by the way, plus cosine x, x cosine x, and this is x sine x minus cosine x divided by x cube cosine cube x dx. Same thing. So after that, I'm assuming this as I1 or I2, then no need actually. Let's see what I want to say. So I have I is equal to the gx was x actually. So x times e the power x sine x and plus cos x. And now since I notice that this both integration has this e the power x sine x plus cos x, so let's combine it and see what will happen, because this will be a troublesome if we keep it alone, perhaps. So I'm taking minus sign out of it and I'm taking a big integration sign, and I have e the power x sine x plus cosine x, and since I have taken this thing common, so from both of the terms I'll have one left over here, and minus I have this x cosine x and into x sine x minus cosine x divided by x cube cos cube x dx. Now notice one thing. If you understand the structure of e the power x format of this result we have established, you notice that what will happen. I need e the power x sine x, means e the power ux, so I have it, and after that what I need u dash x with gx, and plus I need g dash x. So we are thinking maybe it will happen, and so I'm multiplying this thing, so it will become like this: x sine x minus cosine x and divided by x square cos square x. After this, many students struggle to get the format, but we got the format. In fact, you see that why I'm saying this. I'm just writing this thing, and this is what e the power x sine x plus cosine x, and here I'm writing, because you notice this x cos x has derivative this thing. So how this whole thing will come as the form of derivative if I have 1 by x cosine x in the denominator. Is not exact derivative, but what will come? X into minus sine x and plus cosine x. So I can take this plus and I can take this minus, and this will become plus. So now it is cool. And to compensate it, I will multiply with x cosine x. So x cosine x, I am multiplying it, and now I have here is cosine x minus x sine x and divided by x square cos square x. And now try to read it in that language, the formula we established. So this is our e to the power ux. This is the derivative. This is the derivative of ux. This is our gx, and this is the g dash x. Can you notice that? And so the answer for this is gx into this whole thing. So I got here x e the power x sine x plus cos x and minus e the power x sine x plus cos x and into gx, that is 1 by x cos x. And of course I have to add c, and from there I can take this e to the power x sine x plus cosine x minus 1 by x cosine x plus c, and that is the answer. So it takes your patience and also it's a creative thing. It's not kind of autopilot. You have to think in every step what is the next step I have to take. So that's all for today. See you in the next video. Stay math active.